Yeah, I was just checking out some of these problems at the end. I just wanted to send number 11 from the worksheet. It's got a 3 kilogram block on a 30-degree incline. So to draw this, I'll show you get at it. You start with the gravitational force, break it into components. When kids first start this, they're not going to know how long to make this. It always looks awkward, like it's too long or too short. But you want to imagine a rectangle here, where the gravitational force is on the diagonal of the rectangle. And that'll help guide you how long to make this thing. How long to make that one. When you're first starting these, you probably want to generate a right triangle, which means you would copy this force over here to complete the right triangle. And then this would be 30 degrees. And then if you trig that out, you can see this is the opposite, which corresponds to sine. But after you do a few of these, it's probably better just to memorize that the horizontal one's going to be sine, and the vertical one's going to be cosine. To complete the force diagram, you're going to want to put in the normal force, and I guess the friction force for this one. Yeah, there's friction. All right, first question, find the force of friction to keep the block still. So that means the sum of forces in the x direction is 0 because it's not moving, and the two forces in that direction are the gravitational and the friction force. So pretty straightforward. Next one says find the normal force, which is a vertical component. So sum of forces in the y direction equals 0, and those two forces are the gravitational y component and the normal force. I guess in both these, I need to be careful with my signs. I guess these two things are happening in opposite directions, so I will have to choose a direction to be negative. I guess I chose gravity, or the downward direction, to be negative. But it'd be easy to just forget to put that in there. And if I did that, I guess my normal force would have turned out to be negative. All right, part D, find the minimum coefficient of friction to keep the block from moving. So, wait, is that what it says? Oh, coefficient of friction, okay. So in this one, we found the force of friction that keeps the block from moving, which I didn't actually do it. Punch that in the calculator. 3 times 9.8 times sine of 30. 14.7. So in this case, I guess I'm choosing to the right to be positive. All right. So I guess I could just use this equation. I did it differently down here. I kind of recalculated everything. But since this is 14.7, that should equal the normal force. Right, the normal force. I guess that should be positive. Times mu. So I guess this solves up pretty easily. Does that make sense? The force of friction, which we know is 14.7, and this is just the equation for converting normal force into friction in the x direction. Hopefully you're familiar with that. All right, straight. If you are, that's pretty straightforward. So I'm just going to blast ahead. Let me know if there's any questions. Part E says, if the coefficient is half the value found in part T, find the acceleration. So in this case, acceleration is no longer 0, so I'll go back to the sum of the forces equals mass times acceleration, which will be a non-zero number now. The sum of those forces equals the mass times acceleration. So in this case, my force of friction is now different because the coefficient of friction is less than it was before. So luckily I pretty much know both of these numbers from previous problems. Force of friction is the normal force, which I also know from a previous problem. I should have just written it as a decimal, but I never actually calculated it, so I'm just carrying over that calculation. Probably when you do it, this will be some, just some number that you've already calculated from part C. And then they said the coefficient of friction is now half of what it used to be. It was 0.577 for me in part D. The coefficient of friction was 0.577, now it's half. Normal force times the new coefficient of friction equals mass times acceleration. Since all these masses are equal, I'll just cancel those out. And then it solves. I'm left with one unknown in all numbers. That's what I got. One more time, I got to be careful with these signs. See how I have them both negative here, but I know these things are happening in opposite directions, so I need to change that before I continue. So let's see. I guess I'll choose this to be the negative direction. So that means I'll make this the force of friction positive, and that'll make my answer turn out to be positive. I gotta think about that. Is it accelerating downward or upwards? Downwards. So now I gotta think about this later. Should I have expected my acceleration to be negative? I'm not sure. I'll have to think about that one later. But I'm gonna leave my answer positive and just say it's accelerating this magnitude down the hill. Maybe that'll solve that issue.